Okay, I'm here. I'm going to talk to you about Coolbot. Now, Coolbot is supposed to be a low-cost solution to post-harvest losses, especially in perishable commodities. But before I talk about the Coolbot and my pet subject of post-harvest losses, I'd like to take you through my life story, my journey to being a scientist. After I finished my high school and qualified to join university, I was very excited. Life was looking very promising for me. The future looked bright. I was looking forward to, I was the first girl in my village to have qualified to go to university. So I was the talk of my village. My star was rising. But just when things were looking so good for me, disaster struck. I was diagnosed with end-stage renal failure. Yes, my kidneys had failed. So for me, that was a moment of hopelessness, despair. I resigned myself to fate because I didn't know what this meant for me. So I was started on renal dialysis. If you know what dialysis is, it means they get out your blood from the body, they clean it out, they clean it using a dialyzer, and they return the blood to the body. That didn't look like, a life that I had envisaged for myself. So I was on dialysis. So by the time my letter of admission to go to University of Nairobi to study agriculture came, for me, I was wondering, really? Go and study agriculture? Why would I start this journey that I'm sure I'll never see the end? So I was desperate. I remember when I reported to the Faculty of Agriculture in Kabete campus, I walked to the dean's office and I told the dean, you know what? I've been admitted to agriculture, but I can't do agriculture. Look at me. At that point, I was really frail. The dialysis was taking a toll on me. So I told the dean that, you know what, I need to change my course to education. For me, I thought education was going to be easy on me. Yeah, because I figured out, for me, my perception of agriculture was farming. I imagined that as part of training in agriculture, I would be expected to plow some piece of land. I imagined myself with a hoe, plowing some piece of land. I imagined myself on a tractor, and that just, it wasn't going to be possible. So I told the dean, you know what, I need to change. The dean looked at me and he told me, Jane, agriculture is the best course you could have chosen to do. He told me, look at myself. That was the dean then. He was called Professor Daniel Mukunya. Look at me. Would you like to be like me? And I said, of course I would like to be like you did, but maybe in my dreams, really, because I couldn't imagine myself professor in this state, no. So anyway, the dean insisted that, you know what, go back to class. You cannot change your program. You'll do agriculture because it is good, it's good enough. You can't be me. You go to class, work hard, and purpose to be like me. So I went back to class, of course. It's not like he had convinced me, but did I have an option? Because I didn't have a transfer letter. So I went and studied agriculture. I struggled through first year. Yes. I had one leg in class and one leg in Kenyatta Hospital because I had to go for dialysis 3 times a week. So at the end of first year, a whole year on dialysis, it had taken a toll. And the doctors told me that, you know what, Jane, you need a kidney transplant because dialysis is taking a toll. So what did a transplant mean? It meant I needed to raise money. One, I needed someone to donate the kidney to me. So, wow, that was grim. Same dean, Professor Mukunya, he organized a fundraiser at the university, and we raised money for my kidney transplant. My family, they were all tested for compatibility, and thank God, one of my sisters matched me, and she was gracious enough to offer to donate her kidney to me. So in January 1993, 12th, we both went under the knife and we got the transplant. Yes? Well, I've been wheeled to the theater. I remember I looked up and I told myself, who knows if I'll come out of that theater alive. I said almost bye to the world. But I came out, and we both came out well. And that for me was a turning point. It was a turning point because I believed that God had given me another chance in life. So my hopelessness, my despair, my resignation was turned into hope, purpose, and determination. I knew I have to do something with my life. I went back to class. If you look at my first year transcript, it is graced with D's and C's. You'll understand why. I only attended half of the lectures. Second year, so in between first year and second year, that's when I had the transplant. So when I got into second year, I told myself, you know what? Those D's and those C's are going to be A's and B's minimum. So I put my best foot forward and I studied. I completed the bachelor's degree, top of my class. I got a scholarship to go and study master's and another one to go and do PhD. And now I remember the words of the dean. Do you want to be like me? And I said, at this point in time, that looked like reality. It's possible. It is within reach for me. And I told myself, you know what, one day, and you watch this space, one day, I'll be the dean of agriculture, one of these fine days. So that is the science. So I went through this, and it got me to where I am, a scientist. So my purpose, my area of research in agriculture, specifically in horticulture, is post-harvest science and technology. And you want to ask yourself, why post-harvest science and technology? Okay. At this point, I want to acknowledge the African women in agricultural research and development. They're part of my journey that has helped me to shape this focus. Why am I so interested in post-harvest science and technology? Now, as you see on the slide that is cast there, I believe that we have focused so much on production. We are producing. The breeders are doing their part. We have very good breeds of crops and animals. We have high quality. The agronomists have done their part. We can produce the potential that is realized through breeding. So we have good quality. You can see the square watermelon there. That is science. That is technology. That we can achieve anything we want. But I realize that there's one part of the supply chain that has been neglected. And that is what happens to this produce after it has been harvested. Okay? And just like the previous speakers, we are really interested in helping our smallholder farmers to realize because we're spending so much. Yes? We're spending so much to produce good quality crops, but as the slide you can see over there, it is pointing to the fact that not all of what is produced ends up on the table. Production. I want to draw your attention to a report that was recently produced by the Food and Agriculture Organization. Now, this report, the statistic that is cast there on the slide is drawn from this report. This report on food losses and waste in the context of sustainable system has information about the level, the extent of losses. It's not the only report that has been done, but the other reports that have been done before. Now, this report points to the fact that a third of the food that is produced, that is 1.2 billion tons of the food that is produced, is wasted along the supply chain. Now, it gets worse for fruits and vegetables because of their high perishability. That is almost 50% of the fruits and vegetables produced are wasted, lost or wasted. Now that means for every 2 fruits that are produced, one ends on the table, the other one ends where? In the dustbin. Now if that doesn't click, if that doesn't warrant action, I don't know what does. That is why I'm so interested in this topic. Now you want to ask yourself, why are we having such high losses? There are very many factors that are driving these losses, all the way from production to the consumption stage, okay? So I will not labor. Time won't allow me to highlight all these factors. But then one of the key things that is contributing to these losses is lack of storage. Most of our farmers, I don't know about your rural areas, the farmers are suffering. You realize in some farm situation, you find the best a farmer has for a store is someplace under a tree. Now, cold storage is so critical, it's so important in managing in the post-harvest handling of perishable commodities. Why is cold storage so important? Now, if you look at the slide that is cast over there, I did a little experiment to just show how important cold storage is for perishable commodities. I took a batch of, 2 batches of sukuma wiki, that is kales. I put 1 batch in the refrigerator at 8 degrees centigrade, and the other batch I left it at ambient room conditions. Now, if you can look at that slide over there, you can see the difference that cold storage is making. I'm sure you can see that. Within 2 days of storage under ambient conditions, the skuma was unsellable. It was yellow, it was wilted. If you look at the skuma that was stored at 8 degrees in the refrigerator, it was, by 16 days, it was still as fresh as it was at the beginning. And we could still continue to store it much longer. That means, that tells you how important cold storage, among other factors, is key in post-harvest handling of perishables. Okay? So now, if cold storage is that important, how come the farmers are not using it? Why are the farmers not adapting the cold storage facilities that are there? Conventional cold rooms are there, but can our farmers afford these cold rooms? Can they? Maybe not. This Coolbot is actually an innovation of a smallholder farmer. I want to introduce to you Ron Kolsler. Ron Kolsler is a smallholder farmer in the US who, faced with the same challenges as our smallholder farmers, he thought outside the box. Yes, because cold storage, I mean, he's a smallholder farmer. Conventional cold rooms were out of reach for him. So he thought out of the box. Now, Ron figured out that when you have an AC, air conditioner, fitted into a room, like this one, I don't know if this one is air conditioned, usually it is set, the temperature is set to be, minimum is 18 degrees centigrade, okay? Now that is good enough, it makes you comfortable, but it's not good enough for perishable commodities like fruits and vegetables. So Ron figured out, if in fact, what is keeping that temperature at 18 minimum is a thermostat, is there a way you can go around that thermostat and force this AC to work harder and cool the room to much lower temperatures? So Ron invented the Coolbot. So the Coolbot, as you can see there, is a little gadget, as I've shown there. When it is fitted onto a standard AC, it overrides the thermostat in the AC. So just using the AC, which with the thermostat can only heat up to, or cool up to 18 degrees. But with the Coolbot, you can set the Coolbot to make the AC lower the temperature to as much as you want. Okay, so the figures over there on the left is your insulated. The key thing in the Coolbot technology is an insulation. Okay, you look on your left, that is a newly constructed room, insulated, fitted with an AC and a Coolbot. Now, what is the cost of the Coolbot? It could range from $1,000 to as much as it can, depending on the level of sophistication that you're using for that you want for your Coolbot. Okay, so basically, you can make it as cheap as you can, but you can also make it expensive. So for smallholder farmers, of course, we want it as cheap as possible. Now, farmers in Bangladesh, which is this scenario in Bangladesh is not unique because we have the same scenario in Kenya. You've heard of farmers in potato producing areas in Kinangop, Molo. They produce potatoes. When they're in season, the middlemen buy from them. And then a few months later, they have to buy them for much higher price. That is the same scenario for smallholder farmers in Bangladesh. So given the fact that the Coolbot has been there, it's been introduced, myself and a team of researchers from University of Nairobi, Professor Hutchinson, Dr. Willis Owino, some researchers from Kari, Dr. Lusike, and a team from UC Davis, Ms. Britta Hansen and Michael Reid, we teamed up and said, you know, can we pilot this technology in Kenya? And when there was a call from Kenya Feed the Future Innovation Engine, we put in a bid to pilot this technology in Kenya. And we're glad that we were given that grant, and we're actually piloting this technology in Kenya. We are currently in Makueni. Makueni, because I've been working with the mango farmers in Makueni and I feel their pain. They wait for their mango crop a whole season. And then when now mango is coming into season, the amount of losses these farmers incur is unacceptable. So something has got to be done. So I'm working with these farmers. The slide that is over there shows our pilot project. So this is preliminary work. We have stored some tomatoes and kales there. We just wanted to see, does this Coolbot actually work? And how effective is it to cool the produce? So I am glad to report that for the pilot phase, it is perfect. We could cool the room to as low as 10 degrees. So of course, we don't want to get it too much lower than 10 degrees because of chilling injury. So we were able to cool our room and our produce has been stored long enough, which makes a whole lot of difference for the smallholder farmers who we are targeting. What is the biggest challenge we are facing in Makueni, in some of the rural areas? Electricity. Because electricity in most rural areas is not there. If it's not there, if it's there, it is unstable. And in Makueni, that is the challenge we're facing. So looking forward for the Coolbot, what is the future of the Coolbot? We're thinking, if indeed it's going to benefit the smallholder farmers in Makueni, for example, we want a solar-powered AC. Can you think about that? I know in there we have all the expertise we need. Kenya, we are blessed. We have expertise. Solar-powered AC. We're thinking that will solve our power situation in Makueni and the rural areas. The other thing for the cost of the Coolbot, like I said, insulation is critical. Okay. Now, for our cold room that we piloted in Makueni, we have used structure insulated panels which are made from polyester. Now, that is not very cheap. So it has made our Coolbot a little bit expensive than we thought. But there are other low-cost options. Actually, we've figured out from literature that feathers, can you imagine, chicken feathers, can do some insulation. The key thing for us is to bring the cost down. Bring the cost, because if insulation is what is making it very expensive, we got to bring the cost down. And I'm glad to report that we've been working with the Fab Lab of University of Nairobi, because for our project, we had to ship in the Coolbots from the US. Now, that is not very sustainable if we are hoping to roll out this nationally and to benefit each and every farmer or groups of farmers. So we worked with the Fab Lab of University of Nairobi. They helped us to fit the Coolbot for our pilot project. But again, we are in talks. The owner of the technology, Ron Kolsler, does not mind to have these Coolbot assembled in Kenya. Actually, if you look at that Coolbot, it's really not a complicated thing. And when the people from Fab Lab looked at it, they said, this is so easy, they can actually assemble it. But is it possible for them to assemble the Coolbot under license? Now, so those are the thoughts that you're going through, because I see Coolbot making a whole lot of difference. But for it to make that desired difference, we got to make it cost-effective and affordable for the smallholder farmers. So that is where we're going. So this is food for thought for you, researchers in there. We need to roll out the Coolbot to each and every farmer. And let us get involved in this topic, in this desire to reduce food losses and food waste in our agricultural food value chains. Thank you.